This is lesson 1.5, Angle Relationships. The objectives are to identify and use special angle pairs and to identify perpendicular lines. Adjacent angles are two angles that lie in the same plane and have a common vertex and a common side but no common interior points. It's like two slices of pie that are next to each other. A pair of adjacent angles with non-common sides that are opposite rays is called a linear pair. In other words, they form a straight line when you put them together. Vertical angles are two non-adjacent angles formed by two intersecting lines. They make a bow tie. Name an angle or angle pair that satisfies each condition. There may be more than one correct answer for these. We will give just one correct answer. Number 1. Two adjacent angles. Remember, adjacent angles are like slices of pie sitting next to each other. They share a common side and a vertex, like angle LTN and angle NTE. Two acute vertical angles. Remember, vertical angles are formed by intersecting lines, and it looks like they make a bow tie. These two lines intersect, giving you these vertical angles, angle RTS and angle LTE. They look like a bow tie. So those two angles are acute vertical angles. Number 3, two supplementary adjacent angles. Supplementary angles add up to 180 degrees, and adjacent angles share a side and a vertex. Angle RTL and angle LTE are supplementary and adjacent. They're supplementary because when you put them together, they form that line there, and they're adjacent because they share a side and a vertex. So angle RTL and angle LTE are supplementary adjacent angles. Number 4, an angle supplementary to angle RTS. Angle RTS is right there. Supplementary angles add up to 180. So what angle, when put with angle RTS, have measures that add up to 180? One of them would be angle STE. Notice, when you put those together, they form a straight line. So angle STE is supplementary to angle RTS. Perpendicular lines. Lines, rays, and segments that form four right angles are perpendicular. The right angle symbol indicates that the lines are perpendicular. In the figure at the right, line AC is perpendicular to line BD, or it's written like this. Notice the upside down T symbol for perpendicular. Number 1. Find the value of x and y so that line NR is perpendicular to line MQ. So we need these two lines to be perpendicular, which means that we need four right angles here where they intersect. For the x's, notice that the two angles with the x's form that angle when you put them together, and that angle has a measure of 90. So these two angles will add up to 90. 5x plus x equals 90. 5x plus x is 6x, and when you divide by 6, x is 15. And that works because the two angles with the x's together make 90 degrees. For y, the 9y plus 18 also forms a right angle. So 9y plus 18 equals 90. Subtract 18. 9y is 72. And when you divide by 9, y is 8. So remember, when things equal 90, make them equal 90. If two things add up to equal 90, add them up to equal 90. Number 2, find the measure of angle MSN. Well, angle MSN is right here, and it's marked with the right angle box. So, the measure of angle MSN has to equal 90. Number 3, the measure of angle EBF is 3x plus 10, and the measure of angle DBE is x. And ray BD is perpendicular to ray BF. Find the value of x. Well, what we have here is two lines that are perpendicular and two angles that form that full amount, so these two angles have to add up to 90. X plus 3x plus 10 has to equal 90, because these two angles together add up to the right angle. Solve for x. X and 3x is 4x. Subtract 10 from each side, and 4x is equal to 80. And then divide both sides by 4. X is 20. The two angles together made the right angle, so they add up to 90.